December 2025. A software engineer posted about a production incident that had gone undetected for weeks. An external API was returning a count value as a string rather than a number. The code that processed it used the addition operator. In JavaScript, adding a number to a string does not produce a number. It concatenates them. The string 1000 combined with the number 1 is not 1001. It is the string 10,001. The dashboards displayed wrong figures for weeks without raising an alert, without throwing an error, and without crashing. JavaScript ran as designed. It ran into the wrong answer. The language resolves the collision between a string and a number by treating both as text, silently, because that is what it was built to do. This is JavaScript's specific failure mode. Not an exception, not a crash, but a plausible-looking result that runs until someone checks whether the numbers make sense. Brendan Eich joined Netscape in April 1995 with a mandate to build a scripting language for the web browser. The timeline was 10 days. The constraints were specific. The language had to look like Java, which was the dominant technology of the moment. It had to be simple enough for non-professional programmers, and it had to run inside the browser. Eich built a working prototype. He called it Mocha. Netscape briefly renamed it LiveScript. In November 1995, in a joint announcement with Sun Microsystems, it became JavaScript. The name was chosen to attach to Java's popularity. The two languages are unrelated. The design decisions made under that 10-day constraint are still in the language. Type coercion was built in to make the language forgiving, so that if the types don't match, JavaScript tries to reconcile them rather than stopping. The date object was rushed and shipped with time zone handling that has been producing wrong dates since 1995. The behavior of the this keyword inside functions was a design choice that has confused developers ever since. In 1997, ECMA International published the ECMA script standard, creating a shared specification that browser vendors could implement. The TC39 committee now governs the language through a staged proposal process that moves new features from concept through specification to implementation before they ship. June 2015, ES6, the JavaScript Renaissance. Block-scoped variables with let and const. Arrow functions that resolved the this keyword confusion. Classes, modules, and promises. The language that had been built in 10 days became a serious tool for large-scale application development. In 2009, Ryan Dahl had already extended it to the server with Node.js, wrapping the V8 engine in a non-blocking event-driven model and enabling full-stack development in a single language. The December 2025 coercion incident is not an edge case. It is one instance of a category of failures that the language's design produces consistently. The same addition operator that turns a string and a number into a longer string also silently converts booleans to numbers, objects to strings, and null to zero in ways that produce results. The developer did not intend and cannot predict without knowing the coercion rules. February 2025. A developer published a post-mortem on a production analytics dashboard that crashed when a function called the length property on a variable that was null rather than an array. The assumption that data would always be present was not checked. The crash only happened when the API returned null. There was no error before the code ran, because in JavaScript there is no step before the code runs. May 2024. A developer asked on Stack Overflow why the date constructor was showing January 14th when they passed the string January 15th. The browser was interpreting a date-only string in the local time zone rather than coordinated universal time. The question has a thread of thousands of similar reports going back years. The date object shipped in 1995 and kept its original behavior. February 2023. NPM version 9 shipped with breaking changes inside a Node.js long-term support release. Teams that had not pinned their NPM version found production broken after a routine update. These failures share a structure: no warning before the code runs, the bug surfaces in production, and the root cause is an assumption the developer made about types or values that the language was not designed to enforce. JavaScript in 2026 is not the JavaScript that shipped in 1995 or even 2015. The language has addressed its most common failure modes through the ECMA script process. Optional chaining allows property access chains that return undefined rather than crashing when a value in the chain is null. Nullish coalescing provides safe default values that only activate when a variable is specifically null or undefined, rather than treating empty strings and zero as falsy. Both were added to address the null and undefined crash category that generated the February 2025 production incident. March 2026, the Temporal API reaches TC39 Stage 4 and becomes part of ES 2026. The date object that Brendan Eich built in 1995, with its mutable state, zero-indexed months, and inconsistent time zone handling, now has a replacement. Temporal provides immutable datetime types that are explicit about time zones, consistent in their indexing, and correct in their parsing. It is shipping in Chrome 144, Firefox 139, and Edge 144. The bug category documented in the Stack Overflow thread from May to 2024 has a language-level answer. ES 2025 added iterator helpers for chaining filter, map, and take operations directly on iterators, set algebra methods for union, intersection, and difference, and the regexp escape function for safely handling user input in patterns. The server runtime landscape in 2026 has three options. Node.js remains the safe, ecosystem-compatible default for production. Deno, also created by Ryan Dahl, prioritizes security permissions and first-class support for typed files. Bun, built on Zig and Apple's JavaScript engine, is the fastest option for performance-critical use cases. The State of JavaScript 2025 survey put developer happiness at 3.8 out of 5. JavaScript's strongest argument in 2026 is the same argument it has always had. It runs everywhere, with no build step, and with the fastest path from code to visible result of any option available. For a single developer building a prototype, the absence of a compilation stage means changes are immediate. The absence of a type system means there are no type errors to resolve before the application runs. For scripts, utilities, and one-off tools, the overhead of a compile step would cost more than any type safety benefit provides. The argument has a scale limit. The production incidents documented in the research period, the coercion bug that ran wrong for weeks, the null reference crash, the date time zone error, share a structure, the kind of failure that a statically typed language with strict null checking would have surfaced before the code reached production. The assumption that experienced developers can compensate for the absence of a type system is partially correct. It is less correct when a team grows, when data shapes change, or when a code base accumulates assumptions that later developers inherit without the original context. The just use JavaScript position has the strongest case for teams small enough that every developer knows every assumption in the code base. It has a weaker case for teams large enough that developers are making assumptions about data that the other developers cannot see. Below a certain code base size and team size, JavaScript's iteration speed outweighs the cost of runtime surprises. Above that threshold, the cost structure inverts. The Temporal API, optional chaining, and nullish coalescing represent the language actively addressing the categories of bugs it has historically produced. The foundation, however, remains dynamically typed and interpreted at runtime. The improvements narrow the gap between what JavaScript catches and what a statically typed language catches. They do not close it. There is no compile step between the code and the consequence.